Now, writing factored form given the graph. So we're going to be given graphs and we're going to be writing equations for these parabolas. And factored form, we know we can use factored form because we see that it's crossing some points that we can use for the that are on the x-axis where our solutions are going to be found, or our zeros. So there are going to be 4 steps that we're going to apply here. We're going to identify the zeros and then write down as using those zeros, we're going to write them down as 2 linear factors. And then we're going to choose a third known point from the graph. And then finally, we're going to substitute in for x and y and solve for a. So the first step is to choose our zeros that we see here. So let me zoom in on this graph. We can see that the zeros are at -3 and 5. So as far as my zeros go, we have -3, 0, and 5, 0. Then we're going to write this down as an equation. So y equals a times x plus 3. We do the opposite. In order to write the equation in factor form, we do the opposite of our zeros. So x plus 3 times x minus 5. Then we're going to choose a third point. Now, a third point, it can be any arbitrary point. I'm going to go with green on this one here so we can see it. It can be this point. It could be, like I said, it's any arbitrary point. Look, here we have a y-intercept that we could use. I don't want to use the vertex because it does have a partial rather than a whole number. And I do have this point. And then if I keep following, it's kind of hard to tell sometimes where they're at exactly. So I'm just trying my best to pick the ones that look the most similar here, or the most visible. So for the purpose of this one, I'm going to use the 2, -6 point. So I'm going to use that as my third point. So 2, -6. And the purpose of the third point is so that we can solve for a. We don't know what a is. We need the third point in order to solve for it. And since our third point is an x and a y, we're just going to substitute it in place of this equation. So our y is -6. It'll equal a times our x, which is 2. So 2 plus 3 times 2 minus 5. And then all we got to do is solve for a from here. So we have our a, our 2 plus 3 is 5, and our 2 minus 5 is -3. Okay, we'll go ahead and simplify this step here. So this becomes 5 times -3, that's -15. We're going to keep a. So -15a is equal to -6. And then by dividing by -15 on both sides of the equation, we'll see that this goes to positive, which is a very important feature to notice. And we're going to get a is equal to 6 over 15, which reduces, let's see, we have a common factor of 3. I'll try that again. Maybe I can write it. So a is going to equal 2/5. And it's a positive. So if you looked at the graph, it was moving up. So that meant we have a positive a value anyways. So that's a good confirmation to get us where we need to go. And so the final equation is y equals 2/5 x plus 3 times x minus 5. Now, the next step is to take this equation and we're going to rewrite it in standard form. So here, I'm going to pull this over to the side. We now have this in factored form. So this equation's good. So factored form. Then we have standard form that we need it in. So we're going to take y equals 2/5 x plus 3 times x minus 5. We're going to FOIL. We're going to FOIL this part. So this is going to give us y equals 2/5 of x squared minus 5x plus 3x minus 15. We then have y equals 2/5 of x squared minus 2x minus 15. And then we're going to distribute the 2/5 into each term, leaving us with the final form of y equals 2/5 of x squared minus 2/5 of 2, which is 4/5 x, minus, and then 2/5 of 15. 5 and 15 are going to reduce to 1 and 3, so this minus 6. So this is standard form.